Okay, if you'll turn the page, the next drawing in your book should look like this. It's the shaft. This is a lathe part. We're going to do a couple of turning exercises just to reinforce the geometry needed for turning parts. The tools are really the same, just a couple of considerations you need to make for turning. Number one being we don't need the entire shape necessarily, just the geometry needed to drive the tool path. Now, a lot of people would just have an open shape for, probably from the ID up and then around to the back for this part. Possibly another piece of geometry or the same piece of geometry to include the bore here. But I prefer to draw complete shapes for turning. I'll even include the back face of this in spite of the fact that that would be a separate operation. It's very easy to utilize the same shape for both if it has all the geometry needed. And we'll get to that in a minute. But let's go ahead and jump over to Gibbs and get set up to do a 8-inch long piece of material. We'll go 3.5-inch diameter, a little bit of facing allowance, and let's go ahead and get started. So I'm going to go to the document control dialog, and I will always make sure that I have the current part saved. And then instead of hitting new, since I'm switching machines, I like to close the part. And with nothing open, switch my machine to a horizontal lathe generic shank, just a 2-axis lathe. By not having a part open, by not having a milling part open when I switch to lathe, that keeps me from possibly having extra coordinate systems that I don't need in the file. So now I can go ahead and say new, and this part is going to be called shaft. Try to spell it right. So the top section of this looks pretty much like it did for milling. Still choice of inches or metric, still your basic file handling. The only difference is we switch the MDD or the machine to a horizontal lathe generic shank. But in the lower section down here, instead of a rectangular part, we're describing a round part. Now, one of the first things that you want to do is make your choice of working in diameter or radius. I work in diameter. My brain functions in diameter on the lathe. So the diameter of my stock is going to be 3.5 inches. This is the Z value at the front of my stock. I'm going to make the finished front face the origin. I know that it makes better mechanical sense to make the back jaws or the seat that the part is resting against in the jaws the Z origin, but most shops that I've worked with use the front finished face as the origin. So that's the way that I'm going to do this. So I'm going to allow 30 thousandths in front of that for a facing allowance. And then the back face is going to be at minus, I'm just going to say 7.9. Really doesn't matter at this stage of the game. My offsets down here, I'm going to zero those out. They really are not a big concern on a 2-axis lathe. Moving over to this side, my mill class doesn't matter because, again, it's a 2-axis lathe, so there is no milling. The shank size I'm going to set to 1 inch, fairly typical for the size work. This will control the library of tool holders that were presented. We already discussed radius versus diameter. I'm going to go to the tool change and set a tool change position of, say, 8 and 8. 8-inch diameter, 8 inches in front of the face. That should be more than enough to cover the difference between our longest tool and our shortest tool. Back to the workspace. I also have a choice of running auto clearance, where the software keeps track of where material remains, and when it makes rapid repositioning moves, we'll miss it by whatever value I put here, or I can turn that off and set fixed clearance planes in diameter and Z. I prefer, unless I'm on a large, relatively slow machine, I tend to prefer fixed clearance planes, so that's what I'm going to set up here. So I've got 3.5-inch stock. I'm going to go to 3.7 on the diameter for my X clearance. That's going to be 100 thousandths off of this surface 200 thousandths on the diameter is 100 thousandths of actual motion. So do that, and then Z of 0.1. So I'm set up. I'm going to save this. I'm going to X out of the document control, and I'm going to hit Control E to go to my primary view, which is looking from the side of the part. Now, if we look at our drawing, if I start at the front face, we've got just alternating vertical and horizontal lines all the way around this thing. And this is actually fairly typical of a lot of lathe work. Certainly not everything, but a lot of lathe work is journals and faces and journals and faces and grooves, and and you may have some radiuses and some radii and some fillets mixed in there, but a lot of alternating vertical and horizontal lines. So I'm going to draw this using Geometry Expert. So I'm going to go through this a piece at a time. So the first thing that I'm going to do is, on virtually any lathe part, assuming the front face is a line, I'm going to hit 0, enter. That's the front face of the part. So what I just drew is this line right here. The next thing that I want to draw is this line, and that is a horizontal line at 1.5 inches diameter. Now, I know this is kind of weird having this ID dimensioned as 1.5 inches, but it's in 3 places, so the other 2 are actually ODs, which is kind of an odd way of doing it, but I didn't draw the original drawing. So let me go back to here, and we're going to draw a horizontal line, which is already pulled up here. As soon as I hit enter on the 90-degree line, it assumes the next one is horizontal. 1.5, enter. That's all that I've got to give it. All right, the next line is a vertical line at -3. So -3, enter. Next, we have this horizontal line, which is at a 2-inch diameter. It's already on horizontal line. It's already prompting me for a diameter, so 2, enter. Next is this line at Z minus 3 3/4, minus 3.75. Try that again. I think I got a decimal point in there. Minus 3.75. There we go. And then we have another 1.5 inch diameter. We have this face at Z minus 5. Minus 5, enter. Then we have another 2-inch diameter. 2, enter. Then we have this face at Z minus 6. Minus 6, enter. Then we have our OD, which is 3 1/4. 3.25. Then we have the back face of the part, which is at Z minus 7.5. Minus 7.5. Next we have this diameter, which is 3 inches. 3, enter. Move this down a little bit so you can see what's going on there. And then we have this face, which is at Z minus 7. Minus 7, enter. Then this diameter here, which is at 2.5. 2.5, enter. This face, which is at Z minus 7, and then another 1/4 of an inch. So Z minus 7 minus 1/4 is Z minus 7 1/4. So minus 7.25. Then we have this diameter, which is 1.5. We have this face, which is at Z minus 6 inches. Since there's no through hole and I need to come on back over here, I'm going to come to 0. Then we get to this face, which is at Z minus 4. And our front bore diameter is 1 inch. And that's our last piece of geometry, this line right here. We started with this one. I don't want to draw it a second time. So at this point, I want to come over here all the way to the left, click and hold, come over to connector and let go, and it closes the shape out. So this is the geometry that I need for this part. Now I took that slowly, showing you every piece of geometry. I'm going to delete that now, and I'm just going to draw this as I normally would. So starting at 0, then 1.5, and then -3, and then 2, and then -3 3/4, and then back to that 1.5, coming back to -5, and then back to that 2-inch diameter, back to -6, to the OD 3 1/4, back to the part is at -7.5. We come down to that next diameter is 3 inches. The root of that groove is at 7, and then that diameter is at 2.5, and then that face, and I missed a minus sign there. Just come back up and change it, and then bring it back down to where we were at. So we drew that. This diameter is at 2.5, and that face is at -7 1/4. And then we come down to the 1.5 diameter. To the back of that counter bore is at -6. We go to 0. That front bore is at -4, and a diameter of 1 inch, and we close the shape out. So fairly quick and easy to walk through and draw this using Geometry Expert. So go ahead and take a shot at this. Make sure you close save and close the open file that you currently have. Start out with no file open. Switch your machine on the document control to horizontal lathe, generic shank. Fill in your document control, your material size information here. Make sure you get your clearances and your tool change set, and then draw this part.